Hello, Jacobit's Learning website. We do online tutoring. We also do tutoring here at the shop. We're located in Fort Lauderdale, Florida. Let's begin. This is on square roots with factor trees. A lot of you guys are doing this in both middle school and high school, and you might see one or two of these problems on the SAT and the ACT. So let's just get the concept here. You have square roots and factor trees. You must understand that when you're doing the square root of 27, which is written here as the square root of 27, this is the radicand and it's written like that. It's really like stating 3 times 3 times 3 equals 27. So if you see this, they're inverse relationships. If you see this and you were to put this square root over here and you go backwards, you'd be saying 3 times 3 times 3. Now here's the situation. The answer is 3 to the square root of 3. And the square root of 3 is somewhere close to 1.75, but there's a reason for it. So let's go over and see how it happens. I made this funnel here because actually the square roots function down when you're doing a square root. And when you're multiplying, you guys did factor trees when you were in elementary school. So, or, most of you did. So, you think about this. These are all related and they're coming down a funnel to see what's going on. Okay, so if you do a factor tree and you start here at 27, you know that 9 times 3 is 27. That's the elementary school math you learned. And if you didn't, no big deal, but you got to start learning how this works now. You have 9 here, 3 times 9 equals 27. So you have 9 here, which is 2 3s. Now here's the situation. This 3 over here is left by itself. So you just check that off and you leave it alone for now. These two 3's cancel out because 3 times 3 is 9. And as you remember, square root of 9 is 3. So you take this 3 and you put it here. It's where this 3 goes. So this 3 is here. Remember I said to leave this alone? This guy comes over here and he's by himself. So you have 3 to the square root of 3. This is an index. So if you were going to do this, the fifth root of 32, you would get 2. Why? Because 2 times 2 times 2 times 2 times 2 is 32. Okay, you can also break this down. Remember 32 divided by 2 is 16? Well, watch this. 2 times 2 is 4. Okay, so times 2 is 8. And then times 2 is 16. And what would that be? That would be called the fourth root. Some people call it the quartile root, but it's the fourth root of 16 to get you 2. So you see these? All these 2's, they have to work somewhere. And as you remember, the cubed root of 8 is 2. And here's the situation. This is why. Because 2 times 2 times 2 is 8. So you always look for what the index is asking you. And this is asking you for the third root of, or they call it cubed, the cubed root of 64. And when you think about it, 4 times 4 is going to give you 16. And then 16 times 4 is going to give you what? 64. So always look for, sorry about that guys, the equal sign kind of goes off. But you always have to look for what's going on and what it is. And if you forget, always do your math. 16 times 4. I know you guys have Siri. You guys have your own on the phones. There's a calculator, but try to understand the concept. Try to understand that twos are a series of fours, fours are a series of eights and 16s, so that you always know to think in your mind that this four here is here, and you have a two. So this four times one is four, plus two is 64. Here's a practice problem. If you see a square root sign, you need to determine if it is a perfect square or whether there is a constant in front of the square root. So here's the situation. You have a perfect square here. After you take, and we'll deal with this negative later, but after you take the square root of 72, you have 8 times 9. These two threes once again cancel and they come out. But look at this. If you do your factor tree, you had 4 times 2, still 8. And then you left this 2 alone. And then these two 2's cancel. So you had this 2 over here times the 3's here that are going to cancel here. And then when you multiply them outside of this radical sign, you would get 6. And then the square root of 2, which was left over here, would come over and become the square root of 2. So you would have negative 6 under the square root of 2. And the reason I left the negative alone is because you just had one negative. If you had another negative, you'd have something else. Okay? And this is just up here for a reason. This is the answer written another way, kind of upside down, but we did it here, or kind of not even I meant, but we did it here. It's negative 6 and square root of 2. So if you have one negative and that's all you see, you can do the math and then bring the negative. If you want to bring it as you come along, you still would have been multiplying negative 2 times 3, which would still give you a negative 6. Practice problems where you have a fraction. Please don't let these intimidate you. Square root of 32, square root of 49. You guys remember elementary math. 7 times 7 is 49. Don't complicate this. Okay? 7 times 7 equals 49. And so here you are. And the 7 is by itself. You had 8 times 4, which is 32. That's just your math from elementary school. So guess what? You had 3 sets of 2's for the 8 and another 2 sets of 2. You have 1 set of 2, excuse me, for the 4. So you have 1, 2, 3, and then these 2 sets, and then you just look at what cancels. These two 2's cancel, and the number, once they cancel, stays the same. It's 2. Because that's like saying that this 2 times 2 is a square root of 4, which is going to be 2 anyway. Okay? So you have a 2 over there, and then when they cancel, you have this other 2 and this 2, and so you have 2 times 2, because that's the square root of 4. But guess what? 2 times 2 without the radical sign becomes 4. You have one set of 2's left behind. Here you are, and that set comes over here. Here's your answer. 4 times the square root of 2 over 7. Are we trying to do any division right now? Not in this video. That comes out in Algebra 2. And we'll get to that later. But for right now, you're just understanding the concept. You leave it alone. 4 square root of 2 over 7. Okay, for our last slide. Square root of 84, square root of 256. Listen, you see here a 2 and a 6. So you should be thinking of 2's. You see an 8 and a 4. You should be thinking of 8's and 4's. So when you think about it, and you can check my math here to make sure that this is done right, 42 times 2 should give you 2 times 2 is 4. 4 times 2 is 8. It's 84. So now you have this here, and then this is 256. If you want to go into division and you wanted to take, and you didn't know that the square root of 256 is called a perfect square because it's 16, remember, you can always take 2 anytime you see a 6 or an 8 or a 4 at the end. Usually, most times, like 95% of the times, you can always do your math here and you can see what's going on. Sorry about that. That's 0, 0, 5, 2. You get a 4 here. Minus 1. You get a 16. Oops, off the page. Sorry about that. You get a 1. You get a 1 here. 1, and then you're going to carry down the 16 using a highlighter. This is just a straight 0. And then 2 into 16 is going to give you 128. Erase that and go back to my original pen. Sorry about this. Oh my goodness. Okay. So what happens there is now you have a 128. Sorry about that. So what I'm saying is you can always go back down and do 128, and then you have 2 and factor your trees, but keep going until you get to 16 in case you forget. But that's the answer. And I think the answer came out already, but look at this. You have your 2 here, same concept. You are taking out the 2's, 2 times 2, taking them out, 7 times 3. You cannot break these numbers down anymore. So now you go back to this conclusion that you had 2 square root over the 2 times square root of 21 is what it is, over 16. So 2 times square root of 21 over 16, that's going to be your answer. That came up. And if it's hard, just go back and replay and look at what's going. And one of the things I see most of the students doing is they're allowing this radical sign to intimidate them when you don't. It's really telling you what to do. Do you want to take me out and put me over here, or do you want to square me? And once you understand that, you should be okay. Have a great afternoon, everybody. Take it easy. Thanks for watching.